Every single time you type a web address and hit enter, you're kicking off this invisible, super high-speed journey across the entire globe. So today, we're going to pull back the curtain on the magic that happens in those tiny milliseconds it takes for a web page to just appear. I mean, really think about it. It feels instant, doesn't it? But what's actually going on is this incredibly complex and elegant series of handshakes and directions between your device and servers that could be thousands of miles away. We're going to follow the path of one single request from start to finish. Okay, first things first, before your computer can even think about talking to anyone on the internet, it needs an identity, a permanent, unchangeable name that proves what it is. And that identity starts with a piece of hardware. Every single device that gets online, your phone, your laptop, your smart TV, you name it, has one of these. It's called a network interface card, or NIC. It's the physical part, the Ethernet port or the wireless antenna that makes any communication possible at all. And burned right into that hardware is its permanent identifier, the Media Access Control Address, or MAC address for short. The best way to think about this is like your device's fingerprint, or maybe its social security number. It identifies what the specific device is, and it never ever changes. And here's the really cool part. Look at the structure of the address itself. That first half, that's just a code that tells you who made it, like Apple or Dell or Samsung. The second half, that's a completely unique serial number for that one specific device. It's a truly global, one-of-a-kind ID. Pretty wild, right? But, a permanent fingerprint isn't really enough to get things done. You can't get mail delivered to your fingerprint. To actually receive data from the internet, your device needs a mailing address for its current location. And that's where the IP address comes in. If the MAC address is your device's permanent name, the IP address is its current home address. It's not permanent, and it tells the rest of the internet where your device is right this second. So this chart breaks down the key differences beautifully. A MAC address is all about the physical device on your local network, and it's assigned by the manufacturer. An IP address, on the other hand, is about the device's location on the global internet, and it's assigned by your internet provider. One is permanent and local. The other is temporary and global, and they absolutely have to work together. So how exactly does your device get this temporary mailing address? And why does it usually change pretty much every time you connect? Well, most of us use what's called a dynamic IP address. Think of it like checking into a hotel. When you connect to Wi-Fi, a server on the network, called a DHCP server, assigns you a temporary room number. That's your IP address, just for the duration of your stay. When you leave and come back, you'll probably get a different one. And this diagram shows that exact moment. Your device basically broadcasts a request, kind of shouting, "Hey, I'm here and I need an address." And the DHCP server responds, "No problem. Here's a temporary one you can use." Only after that handshake happens can it start talking to the wider internet. But some things on the internet can't have their address changing all the time. Can you imagine if Google's address changed every day? It'd be impossible to find. That's why web servers, the computers that host the websites we visit, need a static IP address. This is like owning a house with a permanent address. It never changes, so other devices always know exactly where to send their requests. And here, you can see the difference. A device with a static IP doesn't need to ask for directions. It already has a fixed spot on the network map. This allows for a much more direct and consistent connection to things like a website server. So really, it all comes down to a trade-off. For us as users, having a dynamic address that always changes is actually great for privacy. But for services like websites, they need that static address for the speed and reliability required to be found by millions of people. And just a quick note on this, the original system for IP addresses called IPv4 only had about 4 billion possible addresses. Now that sounds like a lot, but with every phone, watch, and refrigerator getting online, we were actually running out. So the world upgraded to IPv6. It has a virtually unlimited number of addresses. We're talking 340 undecillion. That's a 340 with 36 zeros after it. We are not going to run out of those anytime soon. Okay, so our device has its permanent name, the MAC address, and its temporary address, the IP address. But how does its request actually get out of the house and onto the superhighway of the internet? That's the job of your router. Let's finish up our analogy here. The router is your local post office. It takes all the digital mail from all the devices in your home network and makes sure it gets sorted and sent out to the global postal system of the internet. This diagram shows its job perfectly. The router sits right at the edge of your local area network, your LAN, and it acts as the gateway to the wide area network, the WAN, which is really just a fancy name for the internet. It inspects every single piece of data and directs all the traffic. So what happens when the website sends the data back? It sends it to your public IP address, your router's address. The router gets the package, and then it acts as the final mail carrier. It remembers which device inside your house by its MAC address made the original request, and it delivers that web page data right to your screen and not to your roommate's phone or your smart fridge. And there it is. Your device's permanent MAC fingerprint gets a temporary IP address to find its way in the world, and the router acts as the traffic cop for the whole operation. This incredibly complex dance happens in the blink of an eye, billions of times a second, all across the planet. It's an elegant, almost invisible system that makes our entire modern world possible. But it does make you wonder, right? When this whole thing relies on these specific, unique addresses, what happens when just one of them goes missing or points to the wrong place? Well, that's when you get that dreaded "this site can't be reached" error, and the whole dance just grinds to a halt. Something to think about next time you click.